Hey, welcome back. Here are a few more examples of the sum and difference formulas. The previous video got pretty long, so I thought I'll throw in 3 to 4 more examples. Sum and difference formulas are up here. You have them available. My first example is talking about, hey, find the exact value of tangent of 19 pi over 12. When I look at this again, I'm like, we don't go in the 12ths. That is not a special right triangle. So the idea is somehow to break this 19 pi over 12 into two angles that we can handle, which means two angles that are special right triangles. And with pi's, with radians, it sometimes gets a little challenging. What you can do is, I'll give you both the options here. Pi over 12 is 15 degrees when you divide 180 by 12. And then when you multiply it by 19, I'm just trying to convert this angle to degree angle. So 19 times 15 would be 190 plus 80, 85? No, 95. So 5, 8, 285. So that converts to 285 degrees. See if that is something you can break down into special right triangles. Like start with the smallest special right, 30 degrees. If I subtract that, that's 200, not 35, but that'll be 255. Now this is a special right triangle, but this is not. Yeah, that's not. Let's start with 60. So if you subtract 60 from there, that's 225. That's a special right triangle. And actually that is 2 because 225, that's 180 and 225 is exactly 45 away. So here's a breakdown. That's one option. Like, oh yeah, I'm like, oh, actually I could break um 285 degrees down into 60 and 225 degrees, and then you can convert it to radians. And this will be, like I said, this is going up in the 45s. That's 180 and that's 225. So if you're splitting in fours, it's 1, 2, 3, 4, and 5. So this would be 5 pi over 4. That's a possibility of split, actually. 5 pi over 4. That's not the only possibility. There could be more. There definitely could be more. Now, if we technically we should be able to handle the 19 pi over 12 the way it is in radians. What you can do is you can like guess and check sometimes. Like trying to split that 19 pi. I'm obviously keeping the 12ths. Can't change the 12th. Like I could split it into 7 pi and 12 pi. That just came to my mind. But this is just a pi, so that's our quadrantals. We can get the values there. But this, again, we don't know in the 12ths. So that was not a good split. Fine, I discard it. I move on. 6 and 13. 6 pi and 13 would give me that. But again, I mean, this is pi over 2. This one's fine. It's this one. It's like, nope, can't do that. 10 and 9, 10 pi over 12 plus 9 pi over 12. That's another split. This simplifies to 5 pi over 6, and that simplifies to 3 pi over 4. And the 6 splits of 6 and 4s, that those will be a multiple of 45 degree, and this will be a multiple of 30 degree. And that's another split that I found. So this method I use, you keeping the radians, and the previous method was I converted it to degrees, then try to do the split, and then convert it back to radians. Either way, either way is fine. The idea is we should be able to do it without having to convert it to degrees. Now, if you notice, I have this split, which is also fine because a thirds means we're going up in the 60s, and a fourths means you're going up in the 45, so that should work. Then this one was another one. Either one's fine. Both of them should give us the same answer. 4, 15, and 12. So now all I'm doing is, now that I've split it into this, I'm just going to use the one I did at the beginning. That clearly is my A value, and this is clearly the B value, and it's a tangent addition formula. So all I have to do is get the tangent formula, tangent A plus B, which is, that's right there, tangent of A plus tangent of B over times B. Now my A and B's, I'm just going to replace it here. A is pi over 3. 5 pi over 4 pi over 3, 4, 4. And now it's time to substitute their values, which again, you can either draw triangles or you can, if you have the unit circle memorized. Tangent at 60 degrees is root 3. And then tangent at 5 pi over 4, which is 45-degree angle, I just know what, 1 here and 1, negative 1 here. So that should be just a 1. And then tangent at the 45s here is negative 1 and negative 1. 1 minus, and these are the repeat values, so that's root 3 and that's a 1. And that boils down to root 3 plus 1 over 1 minus root 3. I mean, we have kind of gotten the value, except we now have radicals in the denominator. If you watch my previous video, to get rid of radicals in the denominator that are two terms or binomials, the only way to get rid of them is to multiply by its conjugate, because that gets rid of the binomial. So in the denominator, I now have, also notice this is now a minus b, that's a plus b, so I should be able to combine it to difference of formulas. So 1 squared, which is 1, and then minus root 3 squared, which will be back to 3. In the numerator, I have root 3 plus 1 times root 3 plus 1, or root 3 plus 1 squared. I'm going to go ahead and FOIL it. 3 plus root 3 plus root 3 plus 1. I FOILed it. I multiplied everything by everything. Now we have 2 root 3 plus 4 over negative 2. The negative can come out here. One last step, I can see that a 2 can be pulled out from here. And just check your undistribution, like distribute it back to see if you get the initial 2 terms back, which I did. So this looks right to me. And then of course 2 and 2 can cancel. So this simplifies to a negative of root 3 plus 2. And that's the exact value of tangent of 19 pi over 12. All right, that was some work there, but it is what it is. Here's a second type of example that I couldn't show in the previous video because it got pretty long. This one's saying find exact value under given conditions. Like find exact value under given conditions. Like what are the conditions given? Let's see. They've given me sine of alpha, and I want to show you alpha beta as well, just so you get familiar with it. They're saying sine of alpha, whatever that alpha angle is, 3/5. Also, they've told me that that angle, alpha, is between pi over 2 and 0. Then that's one piece of information. The other piece of information given is cosine of beta angle, not alpha, that's a different angle now. They're saying that is root 5 over 5 to root 5 over 5. And then they've given me that this beta angle is between 0 and negative pi over 2. See if you can comprehend and see what quadrant this is in. What are they asking me to find? They're asking me to find the exact value of sine alpha plus beta. Whatever that alpha angle is, whatever the beta angle is, I don't know what those angles are, but I could somehow find their values. So let's evaluate what's given. This is what was given to me. This, let's understand the quadrant. This is clearly the first quadrant, and this angle beta is in second quadrant. So I've made some connections that, okay, alpha is in first quadrant, beta is in not second, I'm sorry. That is negative pi over 2, so that's the fourth quadrant, actually. I'm like, okay, whatever these angles are, let's go ahead and draw them. Here's alpha, and here's beta. Okay. Should have connected that first. Okay, fine. They're different angles. They're not reflections of each other. Keep that in mind. They're not reflections of each other. Also, they're wanting me to find sine of alpha plus beta. I'm like, that's a formula. It's an addition. It's a sum formula for sine. Let me go ahead and get the formula. Sine A cosine B plus cosine A sine B. Now A is alpha plus cosine alpha sine B, or sine beta. Okay, let's see what, it's basically about being able to plug in these values here. Let's see how many are no, because some are already given. Sine alpha is given, 3/5. Cosine beta is also given. Then cosine of alpha is not given. And then sine of beta is also not given. I know cosine beta, I just don't know sine of beta. If I can find these two, and these triangles will help me, I'm going to plug them in and solve it. So let's go ahead and do that. Sine of alpha is 3/5, so 3/5 has to be this, which means the adjacent here would be 5 squared minus 3 squared, and square root of that, 25 minus 9, which is square 16, so that's 4. Okay. And then with the beta triangle, cosine of beta is this over this. And like I said, they're different triangles. I probably should have drawn it on a different quadrant because that's gonna cramp it all up. So in the fourth quadrant now, I'm gonna draw this beta triangle. Okay, then I'm gonna label the adjacent and the hypotenuse, and that's the hypotenuse. And I need to find this third side, the perpendicular side. This is the same. I'm gonna use Pythagorean, which is 5 squared minus 2 root 5 whole squared, and then square root of that. That's 25 minus root 5 squared is 5, and 2 squared is 4. 4 times 5 is 20. The square root of 5. But then I have to put the negative by myself because I know I'm under, below in the fourth quadrant. And if you notice here, now that the triangles are complete, I can easily go find cosine of alpha, but I have to use this triangle for it. That's the alpha angle. Cosine is adjacent over hypotenuse. And the sine of beta, I can use this triangle, opposite over hypotenuse. And once I have these, I'm going to start doing some computations here. That's 6 root 5 over 25. Be careful, this is not addition, so you have to multiply the denominators. And honestly, it's not even plus anymore because it's minus, and then 4 root 5 over 25. Well, that nicely, these are like terms. These two are like terms. So you can combine them. 2 root 5 over 25. And 2 and 25 can't be simplified. The sine of alpha plus beta, the exact value, is what we found here. As of now, we still don't know. I exactly don't know what are the measurements of alpha and what are the measurements of the beta angle. They're two different angles. One is in the first quadrant, one is in the fourth quadrant. That's all I know. But if we have all the sides of the triangle, then we can find any ratio, any trig ratio. So that takes care of that. Now I'll show you another one similar type, and then we'll call it done for this video. I think this is third example. This one says same, find exact value of alpha minus beta if what's been given to me. This time they've given me tangent of that alpha angle, and that tangent value is a negative value. Keep that in mind. Also, they're telling me that alpha is less than pi and greater than pi over 2, so I can make the connection in my mind by myself that this is the second quadrant, right? That's 90 degrees, and that's 180, so between 90 and 180. Then they've also given me the cosine of the other angle, the beta angle. What they're saying is half, so it's a positive value. And then they're also telling me the beta is between pi over 2 and 0, so clearly between 0 and 90 would be quadrant 1. I'm like, okay. Now they're wanting me to find sine of alpha minus beta. The first thing I'll do is obviously go get the formula for it. Sine A, cosine B, cosine A, sine B. Sine A, cosine B minus cosine of alpha and sine of beta. Okay, let's see which ones do we already know. Sine of alpha we don't, cosine of beta we do, cosine of alpha we don't, and sine of beta we don't. So let's go ahead and construct our triangles. So that should take care of it. This is in quadrant 2. in quadrant 2, right there and right there. Tangent is negative in quadrant 2, so that works out fine. Opposite over adjacent. Now this opposite cannot be negative, so it's the adjacent that has to be negative. And then we'll do our Pythagorean, and this will turn out to be 5. Hypotenuse is never going to be negative, so this is not going to be negative. Do label that this is the alpha angle. And then this one in first quadrant, cosine is adjacent over hypotenuse. And that'll make this square root of 3. Even if I don't do Pythagorean, we should know that 1 and 2. Also, this is beta angle, by the way. Right. In this case, I can figure out beta angle. I mean, we know it's a 60-degree angle just because it's special right triangle. It just happens, so we have figured out beta here. But alpha, we still don't know. Now I can find sine of alpha because all of this is available. So opposite over hypotenuse. Please make sure to go to the correct angle. Alpha, you'll go to the alpha triangle. And for beta, you'll go to beta triangle. And the cosine of beta would be the cosine of alpha. So for this, I'm going to vote here. I almost went here. Okay. Cosine of alpha is negative 3 over 4 adjacent, not 4, adjacent over hypotenuse. And then sine of beta, this will, for this triangle, is opposite over adjacent hypotenuse. And I'm almost done. So that's 4 over 10. That'll be plus now because two negatives make a positive. Root 3 over 10. And this can be combined. 4 plus 3 root 3. There are no radicals here. In the denominator, there are no radicals. So it is what it is. There we go. We have found the exact value. Alrighty, see ya in the next video.